Hello and welcome back. Now we're going to look at how do we actually find the concavity and inflection in example here. We have a function x plus 2 to the third power, and what we are going to do is first of all find out what its first derivative and second derivative looks like. The first derivative of this function is 3 times x plus 2 to the power 3 to the power 2 rather, and the second derivative is six times x plus 2. Now, in order to find the concavity of this function, we will have to see where the first derivative is increasing and where it is decreasing. Now, first of all, if we look at the first derivative function and set it equal to 0, you will see that point where the first derivative is equal to 0 corresponds to x equal to -2. So at that point, it's not increasing or decreasing. Let's look at the region to the left of -2 and to the right of -2. So in other words, we have two regions to consider, -infinity to -2 in that interval, and then we have from -2 to infinity. At x equal to -2, the slope being equal to 0, which is excluded from consideration. So let's look at this first region, and let's take 2 points in that region and figure out what exactly is happening to the derivative. Now let's take 2 points in that region. Let's say -10 and -8. -10 is less than -8. Prime of -10 is 192, and f prime of -8 similarly. So you got these two numbers. As you can see, when -10 is less than -8, f -10, f prime of -10 here, it is actually greater than f prime of -8. What does that tell you? The derivative is decreasing. So that means it is concave down. So let's consider the region -2 to infinity, and let's again take 2 points in that. I need 2 points. Let's take 0 and 3. 0 is less than 3. And let's find out what is f prime of 0, 12. And f prime of 3 is equal to, and 0 is less than 3, but f prime of 0 is also less than f prime of 3. So when 0 is less than 3, f prime of 0 is less than f prime of 3, we can simply say the derivative is increasing. Derivative increasing means it is concave up. So we have a function that's concave down in one region, -infinity to -2, and then it is concave up from -2 to infinity. Let's get a function which is given to us. Fx is x plus 2 to the power 3. Here I show you the graph of this cubic function in the xy plane. It is going through 0 at -2, and then it's keeping on increasing. And what we just found recently is from -2 to infinity, towards this side here, it's concave up. And towards this side, it is concave down. So, as you can see, it does seem like it's concave up and down, and let's further verify it using the second derivative test. The second derivative of the original function, f of x, x plus 2 cubed, we already know that was equal to 6 of x plus 2. And as you can see, when the function is increasing, when the derivative is increasing, the derivative is increasing when, if x is greater than -2, if we take a value x greater than -2, f prime of double prime of x will be a positive number. Positive.